Now this is your model, and today I will repeat how to assign load. Okay, last time we were on the load application, so let's see how to apply loads. Let me turn to the right. Please don't sleep. And give me that attendance page back, okay? If you finish, please give me back. Okay. Now please see, you have to, because all these loads are acting on the slab, so you have to assign all these loads as area loads, okay? Select all the areas like this. Click inside the area to get selected that particular area, and then go to assign area load, and then over here you have the two choices. Number one is the gravity and other is uniform. You can select any of these two, okay, but make sure what units you are working. Like here the units are Newton millimeter. If you click on here on the uniform loads, you have the units over here. Can you see here? Yes. And you can change the units over here like kilonewton meter. And there is no need to apply that load, because I told you that load we have kept this as a self weight, and the SAP will calculate this self weight by its own function. So we will assign surface finish load. We already assigned surface finish load that day, but if you want to reassign, you can again give the value over here, okay, and you can check this box, replace existing load. If you check this box and you will add value here, it will replace the existing load. You understand? Okay. For example, and if you want to see that either there are some loads or not, you can just right click and here loads. Now if you click here loads, you can see what type of loads these are acting on this slab. So surface finish load and live load. Wall load is acting on the beams. Again, if you want to see in kilonewton meter, you can change the kilonewton meter here, and you can go here to previous. PS means previous selection. If you click here, actually now it is the previous selection. So just select all and right click and load. Now you can see that these are the loads in kilonewton meter. Let me see. Actually, why there is no value here? Okay, if you want me to reassign these loads, I can reassign them. You understand? There is another way you can see the display load. For example, you can go here and display. Wait. Show load assigned and area. Click here area and surface finish. Make it okay. Now you can see these are the load assigned. Okay. Just to make sure that what value you have given here is acting here or not. I'm little confused. It is 173 kilonewton per meter square. It's a very big value. I mean, I think we have done some mistake in the units. Can you see? Yes. It is 173 kilonewton per square meter. It should be around 1.73 kilonewton per square meter. Okay. So let's select all of them. Now let me see. Again, if you go to display, show load assigned area, and you click here the live load. Again, it is 300 kilonewton let's see kg. It should change, but it is not changing. If you go to Newton meter, no.
Maybe we should change the order before and
you mean we should change the order? This 0 0 means x, load in x direction, load in y direction, but we have the load in z direction. Okay. Anyhow, let's see. I think zeros are correct, but there is some problem with the software. Okay, now you have that load. Now let me see if there is a wall load. You just click on the beam and right click and see the load. No, there is no wall load because it is the interior beam. We have applied the wall load only on the. Now click on any exterior beam and click right, and then go to the load. You can see it is in Newton meter. And if you click, it is 13 kilonewton per meter. Can you see here? This is the force at 0 location and force at 7th location, kilonewton meter, because it is a distributed force, UDL. Anyhow, for example, if you again want me to assign these load, I'll just tell you how to assign the area load. Just select all the area, go to assign, and go to area loads and gravity or uniform, any one of these two. For example, if you click uniform, just select the units in which you want to apply the load and give the value here. Because I have already applied these loads, so there is no need to give any value. But if you want to give a new value, you can just give here and check this box. If you check this box, add the existing load, it will add this load into the previous load. Okay? So please make sure what box you are going to check. Okay? And in the same way you can apply surface finish load, wall load and live load. I have already applied all these loads. Wall load is acting only on the beams and this load is load per unit length. Okay? Now we have a shear wall. We have a shear wall. If you are working in the latest versions of SAP or ETAP, you can draw the shear wall in plan. For example, just like area, you can draw the shear wall in plan. But there is no option here to draw the wall in plan. So you can draw the wall in elevation. Now, if you remember your building, I have given you the drawings on the very first day, and you have a shear wall here, 1.5 meter, 1.5 meter. You have two shear walls in these two locations. Okay, so now should I add this shear wall, or you can draw it? Okay, so it means we need one grid here. We need one grid here, 1.5 meter from grid 3, and we need two grids here, one grid here and one grid here to draw the shear wall. Okay, now let's add this grid. So first add a grid 1.5 meter from 3 because the width of shear wall is 1.5 meter by 1.5 meter. Okay. Okay, now let's add. Right click, edit grid data, modify and show system. So you want a grid 1.5 meter from 3. Okay. So how much will be the distance from 2? Let's say this grid is, the name of this grid is 2A, and minus 10.5 minus 1.5, it will be 9. Now if you click primary, it will be primary grid. Primary is the main grid, and if you double click, it will become secondary. You can check any one of these two, it's okay. If you select secondary, it will not appear with the bubble. But if you click final, it will be just like your other grid. Okay, click here show and start. And then okay, so this one grid is added from 1.5 meter from grid 3. Now because the size of your shear wall is 1.5 meter, so it means you need one grid here 1.5 meter and one grid here 1.5 meter. Okay, so D, you will add one grid here like CA and DA. So CA will be, now let's add grid, edit grid data, modify and show system, and let's add CA, and CA will be now grid D minus 1.5 meter. It will be 11.5 meter. Primary show and then add DA. It will be 14.13 plus 1.5. See. Now your grids are here. Once you have provided the shear wall, you can delete these grids or you can hide these grids because we don't want to see them. Okay, how you can do that? Now please, I told you that we cannot draw the shear wall in the plan, so we must have to go in the elevation. So let's go to the elevation 2A. So it will be XY, XZ elevation, and then go to the 2A. Why it is like this? Okay, now I think I can change the layout. Let me change the layout. I go to R, properties. Okay. Now this is your grid 2A. In the latest versions of SAP AutoCAD, if you click here XZ, you will see the number of all the elevation. You can just click on that elevation, but you can go. But because it is an older version, so you have to go from here. Now please see here. It is 2 and this is 2A. Now if you want to draw a wall here, just click draw rectangular area or any of these two. For example, draw rectangular area and wall, and just click here. Sorry. Now if you want to replicate this wall, you can replicate at once. But if you want to draw this wall without, for example, if you don't want to replicate this wall, so you can draw this wall maybe full height of the building. Just if you click here on this wall, okay, wait, so just click in the area. If you select this box, so it will draw the wall. Okay, now if you want to add some door, you can do it, but for that you have to add the extra grid for the door. You understand? And similarly, now you can go to the elevation. If you click here and you fill object, it will show you something like this. And now you have to go on which elevation? Just go to the plan XY. This is your plan CA and DA. Before that, you have to go to the grid 3 XZ and then go to the grid 3. I will add here. This is the back side of your wall. Now go to the YZ. This is now, make sure, for example, you can go to the XY, to CA and DA. You have to add one area here and here. So CA, D and DA. At these three locations you have to add this area. So again go to the YZ, CA, and then DA, D, and then go to the one more. Now just see here. I click here and I go to the fill objects. See. Okay. Now you just click this. Go to the XY. Now this is your slab. Okay. Now the problem is that your slab is overlapping with the shear wall. You want an open area over here. Again, this is an older version, but in the newer version you can add openings here. There is like, if you click here, so there will be like opening. Sorry. But here I think it is not, so edit. So what we can do, we can delete these two areas and we can add them again. For example, again we can add them like this. Slab. Yes. If you want to make one slab, you can make, but if you want to make three slabs, you can make three slabs. Like this. Okay? Yeah, but now you have to again apply the load. Because your load, because once we deleted the area, your load was also deleted. So now you have to again apply the load here. Change kilonewton meter and apply, assign area load, gravity. So give the surface finish load. It was how much? 1.73. 1.73. Okay. Why it is showing? Okay, let's add all again. Okay, I select all the areas because I have little doubt about the units. There is some problem with the units. Select all the areas. Okay, and assign area loads.
All the areas, beams.
Yeah, I mean beam is not an area. You are applying area load, so it will automatically apply on the area. Beam is a line element. Okay. Now go to the gravity. 1.73 kilonewton per square meter. Replace the existing load, make it okay. Now you can see all your loads are same. Again click here. It is PF means previous selection. Again go to assign area loads, gravity and live load. Okay, and how much is the live load? 3. Okay. So now these are your loads. Now what you can do, you can replicate all these floors to the next level. Now we are ready to replicate our floors So now select all those elements which you want to replicate. Because I don't want to replicate the shear walls, so I'm not selecting them.
It's not like that. One more.
Which one?
Not that she won't. Yes.
Okay, now we have to replicate in the Z direction. Go to edit. Our first story height is 4 meter. Okay, I said it. Okay, so first story height is 4 meter. So add D is at 4, number 1, and make it okay. Now you can see it is replicated. Okay, all of your load is replicated, but columns are not replicated. So if you want to replicate the columns, you must have to select the columns and you have to replicate.
But we don't want to replicate.
Yes, we don't want to replicate because our next story columns are different. Okay?
So duplicate once and then
Sorry?
duplicate once and then change.
Now, yeah, for example, how we do, now again go to the elevation A, X, Y, give me the attendance sheet, X, Y, this is X, Y, okay, now this is the first line here. Now you can start adding your columns. For example, draw column 300. Now if you don't want to replicate columns, you can draw all your columns at once. Now because your columns are same. Okay, similarly click here, go to the next elevation. Next, there is no column here. Okay, next. Now, if you change the column size here, it will change it. But don't do it. Let's see what happens.
So the one before it is
This one?
no.
There is no column here. It is the extra grade 2A. This is an additional grade 2A.
Grade 2 such one direction.
Okay, wait. So if you see that this is your XY plan, it stopped working. Okay, this is XY. Now see XY. Now at grid 2A, there is no column.
You meant to add 2.
At 2? Yeah, we have. Okay, let me see at grid 2. You mean?
Yes, that's what I
Okay. I thought you were saying I have not added the columns in the grid 2A. Okay. Similarly, you can see from the other side, other grid YB. See YZ. Okay. Now next. Again, now you go to the XY plane. Now you are at equation 4. Select all, sorry, anything missing, please make sure. Okay. I'm just making sure that everything is selected. Okay, now again go to the edit, replicate, and now you have to replicate 2 times and your story height is 3.5 meters. We did some mistakes again. Select again all. This is Z4, edit, replicate, in the Z direction. No. Okay, let's add one by one. But it should. I don't know.
Does it add up or should be 7.5 seconds? Spacing difference is good.
Maybe 3.5 from
Should be 7.5.
I don't know. If we are selecting from 4, then it should be 3.5.
Starts from origin.
It is DZ. It is not from origin. DZ means that
Try 7.5.
go to the previous section, edit, means 7.5 here?
Yes.
I don't think so.
plus.
But if it is so, then it is not the right way. Because it is saying DZ, and DZ means, okay, previous section. Now you want to add 10.5, 7.5, 11. It is DZ. I mean, I don't know, but in the other all of the software it will work like DZ. Okay. Now you see in the 3D view. What is this? Okay, now let's see what will happen. I will tell you how to fix your model. There is some problem with this version of SAP. I know this. There is some problem with this version of SAP. I'm sure. Anyhow, you click the extrude view. So this is your building. Again, if you want to add the doors in the shear wall, you have to add extra grids in the Z direction, and you have to just add only the wall where it is required. You can do it, but it will take some time. Anyhow, now what is missing now? Sorry? Opening in shear wall, I told you that in this version of SAP, there is no place for the opening. But if you want to add, you can add by adding the grid.
This is structure of foundation.
This, now you see that your first column size is heavier here, and the rest of the column sizes are smaller. Okay, now we have one thing left, and that is support. Do you assign the support condition for the column? No. Okay, now I tell you how to assign the support condition. For reinforced concrete buildings with the footing in the soil, we have what will be the condition of the column, the bottom condition? It will be fixed, hinge or pin? It will be fixed. Okay. Now see how to assign the. Now with this view, with the extruded view, it becomes very slow. So it's better to change the view to the yes. But before that we have to wait. Stop working. I'm sorry for it. Actually, I told you that my PC is 4i5, but I have many things in my computer, and if you click here, yes, now it will be much more comfortable to work. Okay, now where are the column support? Which level? It is at level. Now please see, it is this level. These are the column supports. Select, and these are the wall supports. These are the wall supports. Okay. Select all of these because we have the fixed angle condition at the base. Now all of these joints are selected. Go to assign joint restraint. Assign joint restraint, and which will be the fixed support? This one. Click here. Okay. Now you see the fixed support is added at the base of every column and wall. Now we are. What is missing now? Partition walls we do not add because partition walls do not have any role in taking the load. You understand? This is the main skeleton of your structure which is going to take the load. Anything which you will add later on it, it will be the extra load, and you have already considered in the form of wall load and live load. Okay? So whenever you see any construction, you see this type of building. This is the main load carrying structure. Stairs. Again, you can model stairs. Because stairs is also the type of slab. You can model stairs, but stairs, again, there is stair design in the new versions of the SAP and ETAP, but stair design is nothing like one-way slab design, and you can consider the stair load on the beams. You understand? For example, if there is a stair and beam is supporting a particular stair, you can consider the load of that, because you know the tributary area, you know the length of stair, so half the length multiplied by the load per unit length per unit area, it will become the load per unit length on the beam. Just add it. Footing we cannot model here. In the stair, we will do it on the stair. Now it's ready for the analysis. We can go to the click here, go up. Okay, now I just click analyze. Yes.
Why there is joint at the end of
These
for beams? Yes.
These joints for drawing. Because I think you were not in the last class.
Not a grid. I meant joints.
Yeah, these joints you can remove them, but we added them.
Will not affect on.
It will not, because they are the null joints. They will not affect anything. Go to analyze, set analysis option. You can set the analysis. What type of analysis you want. For this type of building, we have the 3D analysis, and we will make all these checks. It means when all these boxes are checked, it means that you are doing a 3D analysis. If you make XZ plane, it will do the analysis in 2D plane. If you make XY, again is the 2D analysis. So make it okay, and then in the latest versions of the SAP and ETAP, there is one command which is known as check model. You can check your model before analysis if there is a mistake or not, or you can check your model at any stage if there is a mistake or not. But in this version of SAP, there is no such command. Okay, let's see. So the only way to check is to run analysis. It will save it before. Now you can see these are the linear static analysis, but for some load, if you want to go for the linear non-linear static or dynamic, you can add it. But these are the most common type of linear static is the most common and the basic type of analysis.
What about model?
Where?
Second.
Model. Model is basically the dynamic analysis. It will tell about the mode shape. What is going to be the mode shape of the building? It will be vibrating the first mode, second mode, third mode. Because you have not studied the dynamic analysis, and you are not able to understand this model analysis. Okay? Make it okay, and let's see how long it will take. I am not personally satisfied with this version of version 14 because it is very basic version and it has a lot of troubles.
Here, love civil.
Yes.
The best similar to weekends.
Yes, you will enjoy that version. You see, it's the basic version. It's very basic one. It is 2010, I think. Now it is doing analysis complete for different load cases. Okay, now click here, and now start animation has gone somewhere. Okay, click here, and now you see this is the deformed shape of your structure under the you see dead. Now let's see at dead load how the structure will behave. For the dead load, this is going to be here. Sure. Now you see, now for example, stop here. It seems okay to me for the time being. It seems okay. Okay, now go to. Now please see, now it is the most important thing which I am telling you, and from where I will ask most of the questions from your exam. This is now what I will talk, it is most of your questions will be from this part. Yes, for the project. Okay, now please see, if you want to see the deformed shape for the earthquake load, go to display, show deformed shape, and change here the load type. Earthquake X, and make it okay, and start animation. So it seems okay to me. Because how I can say that, because if I remove this column, your building may be very okay. You can try, you can remove some column and you can check. Either you will try to solve or the deformation will be very high, or these deformations are very within a range. Now I tell you, no, it will not fall down, but it will show you a very long deformation. I don't have time now to go for such because it is very, but you can try at your own. You can remove some columns and you can see what happens. It will not fall down, but it will show you a very big deformation. In the model, maybe one slab is twisting like this. Now let's see. You want to see a deformation here. If you just put your cursor here, at any joint, you can see. Now your units are meter. U1 means U1. I told you these directions. Now please see. And now it will show the deformations in millimeter. Here now the maximum deformation is 11 millimeter. It is nothing. At the top of story, under the earthquake load, this is one direction. X. This is 2. And 3 is the vertical. You see vertical deformation is very small. R1 is rotation, twisting. So R1 is twisting in this direction, R2 is twisting in this direction, and R3 is torsion. Now the maximum deformation at this joint. Now this is the most critical joint. You know why? Because it is the highest point, and at highest level the earthquake forces are maximum, and the maximum deformation is 11. For code allows you, UBC allows you maybe H over 200. Now how much will be the H over 200? Can you calculate? Your building height is 11 meters divided by 200. Zero point 55 millimeter, and it is 11 millimeter. It means it is safe.
So 55 is the maximum.
Yeah, 55 is the maximum. But I have just given you an example. For some cases, it is H over 100. For some cases, it is, for example, for the vertical horizontal deflection, it is H over 360. The length of being over 360. The horizontal deflection should not be more than that. But for the first portion, H over 200 will be very small. It will be 20 millimeters. Okay. Now I tell you how to see now the next thing, you can see the deformed shape in any direction. Now please see here. Now you want to see the bending moment and shear force. Now at any elevation, for example, at this elevation you want to see the bending moment and shear force. You just go to, for example, make it x3 or y3. This is your first elevation. Yes, this one. Now you want to see the bending moment and shear force. Go to display, show forces and stresses and frame. If you click here, now see here, M22, M33. Now remember what I told you when I was telling you the section, that M33 is basically your bending moment about with what we design for most of the time, that is M33, and the shear is V22. V22 is the vertical shear, and due to V22 the bending is M33. I explained you, those who attended my class. Let's see, shear 22, you can see one force at one time. Now see the bending moment diagram. So this is the bending moment diagram due to this load combination, and you see it is not very bad. Why? It is what we expect. The positive moment at the center of beam and negative moment at the support. You can see, now you want to see in kilonewton meter. For example, for this beam you want to see, right click, just click on the beam and then right click. Now you can see for this beam, for these loads, this is the main combination 1.2D for what we designed, and if you move your cursor here, now this is the shear force diagram, you see here, can you see? And this is the deflection. So the maximum deflection is how much? Only maximum deflection is at the center, and it is only 1.1 millimeter. It is nothing. 1 millimeter is nothing. It means now I think our design will be okay. I think the beam sizes and the column sizes are okay. So in this way, now you can see, for example, next, this is the next elevation, next, and similarly if you click on the YZ, XZ, now these are your frames. You can see the shear force diagram and the bending moment diagram like this. Okay, because you have a wall here, so again, where there is a wall, your bending moment is changed. Okay, for anything, now for example, this is for this load combination. You can see for any load combination, display forces and stresses. You can see, but basic load combination. For example, for service load, just dead load and live load, you want to see M2, it will be very small. M22 will be very small because our load is mainly in the C direction. See, no bending moment. Because all loads are, because these two loads are in the vertical direction. Due to vertical load, there is no horizontal bending. Horizontal bending will be due to earthquake loading. See here. Earthquake X. No, maybe due to earthquake Y. Maybe not due to earthquake Y. It will be because the earthquake loading is again lateral loading. Yes, no. Yes. So there is no M22, you can see here, because there is no horizontal load acting on any beam. Okay, now next, what I want to tell you, design. The most important thing, design. The last thing and the most important thing is the design. Now, this is your 3D model. Wait. Okay, now you see a lock here. Now you cannot make any change in your model. Now you cannot make any change in your model. If you have to make any change, you have to unlock your model. Once you unlock, your analysis will be deleted. Okay. Now please see how to design it. Now just go to design, concrete, and this is a design code. I told you we have already given the design code in ACI 318, but you can change any